In this question, you were asked to pick the most stable chair conformation of the structure shown in the box. And a lot of people incorrectly choose this first structure or this structure down here because they immediately see three substituents equatorial and think that that must be the most stable. If the question had just asked which of these four chair structures is the most stable overall, then it would be okay to select one of these two structures. But this is specifically asking about the structure shown in the box, and neither of these two structures match the one in the box. So what we want to do is just develop a numbering scheme to keep track of everything. So I'm going to put the tert-butyl at 1 and number clockwise. And let's do that with each of these chairs. And I'm just going to number out to 3. And remember, I'm numbering clockwise. So what we find is that in our original scheme, tert-butyl's at 1, ethyl's at 2, methyl is at 3. So which fit that criteria? This first one fits that criteria. This second one fits that criteria. This one down here, the substituents are in the wrong locations. And the same thing goes with this one down here. So we can eliminate these two. So in the top two structures, the substituents are in the correct location, but we need to be sure they're in the correct direction. So remember that all of these on the ring are out. And out equals up on the chair. Okay, so in our first structure, the tert-butyl is up above the plane of the chair. The methyl is up above the plane, but the ethyl is down. So this structure does not match the one shown. If we come over to the one on the far right and draw a plane at the carbon of the chair, all of these are up. And that matches the original structure. So this is the correct answer.